Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and in this video we're going to be implementing the enemy's death animation. We're also going to give the player score depending on which enemy was killed and what the enemy was doing when they were killed. For example, the state of the enemy, if they were in formation or if they were diving. So let's start off by going to our enemy.h, and the first thing we're going to do is add an animated texture in this class. So in the protected section here all the way at the bottom, we're going to add an animated texture pointer. We'll call this one death animation. So a lot like what we did for the player. Now we're going to go down here as well and remove the handle dead state equals 0 and then the render dead state equals 0. Because we want to handle these two states in the enemy as a whole for all enemies, because they all share the same death animation. There's no point in handling it separately for each one. The boss is a bit of a special case, since when they get hit, they switch textures and then they get destroyed in the next hit, but we're gonna handle that later on. Okay, so the first thing that we need to do now is to initialize our animated texture. So let's go to our enemy.h or enemy.cpp, and then here in the constructor all the way at the bottom, we're gonna go down to right after the MID equals the physics manager, and then we're gonna say mdeath animation is going to be equal to a new animated texture. And for that I made the animated texture and I named it enemy exp, so enemy explosion.png. so my offsets were 0 and 0, and the width of the texture for each sprite was 128. So 128 by 128 was the height as well. There were 5 sprites and 1.0f for the animation type. And then the animation is horizontal, so we're gonna say animated texture horizontal. Now we need to set the parent, so we'll say mdeath animation parent is this. And then we're gonna center it, so we're gonna say mdeath animation position is vector2 underscore 0, so vec2 underscore 0. And mdeath animation wrap mode is animated texture wrap mode or once, animated texture once. And that will be it for initializing our death animation. We will also need to clear it in the destructor, so let's take care of that now before we forget. So we'll say delete mdeath animation, and mdeath animation is going to be equal to a null pointer. And yeah, that's it for initializing the death animation. So next up, let's implement these states. So handle dead state first. So right under handle formation state, we'll add our handle dead state. And for this one, what we're going to say is if mdeath animation is animating, mdeath animation update. Okay, now let's move on to our rendering. So for the rendering, we're gonna have render dead state. So let's implement this one right underneath render formation state. And for that, what we're gonna do is just render our death animation. So we're going to say if mdeath animation is animating, mdeath animation render. So the same idea as the update. If we're not animating, there is no point in rendering it because the explosion is supposed to disappear once the animation is done. So that's pretty much all we need inside this function. Okay, so now that we're handling the death state, we can handle the enemy getting hit. So let's go back to our enemy.h And then underneath here, underneath dive, we can have a boolean called, oh, there we go. So in here, we're going to have a boolean in death animation. And that's going to tell us whether or not the enemy is animating after it died. So let's implement this one. And for this, all we need to say is return mDeath animation is animating. So if the death animation is animating, then we are in our death animation. And that's pretty much it for this one. Now let's go back to our .h, and we need to implement the hit function. And for the hit function, we're going to put it here underneath the destructor. We're going to say virtual void hit phys entity pointer other, and then override. So we're overriding the hit function from our phys entity class, and then let's implement this. For this one, we're going to say if the current state is equal to the formation state, what we want to do is to say parent is equal to a null pointer. And the reason why we're doing this is because if we're in formation, it means that our parent is the formation that we set when we enter the formation. So join formation, we're setting the parent to be as formation. So what we want to do is to remove that parent. So we're setting it to null. And then mCurrent state is going to be equal to dead. And that's the basic function of that interaction inside the enemy class, is because almost all the enemies would die instantly, for example the butterflies or the wasps, but we can handle the boss separately, but then the boss on the second hit, it still dies. So this is the basic interaction that we want to happen for all the enemies, and then we can specifically change it for the boss later on. And that's pretty much it for our enemy class for now. Let's move on to our other enemy classes, the inherited classes from this one, and implement the hit function for each differently, because the hit function, even though they all die the same, they have different sound effects and they have different scores to give the player. So we need to implement that separately for each enemy. So let's first start with the boss. In our boss.h, what we want to do now is to implement our hit function, but we also want to say to figure out if the player was hit before or not. So let's start by adding a boolean called m_was_hit, and that's going to be true after the first hit. We will also want to remove the handle dead state and the render dead state. We don't need these two in here anymore. And then at the bottom, we're going to say void hit phys entity other override. So we'll override the hit function from our parent class. And these are all the changes that we need to do in the .h. So now let's go to our .cpp. In here, we're going to go down to the constructor and initialize our m_was_hit. So m_was_hit is going to be equal to false. There we go. And then moving on to our function that we just added, which is hit, we can implement it all the way at the bottom. And now say if m_was_hit enemy hit other. So we're saying that if we were hit before, we want to just call the enemy's hit function, which is the basic interaction to just kill the boss. But if it wasn't hit before, so we'll say else was hit is going to be equal to true to set us up to go into here the next time around. And then we'll say delete m textures at 0 And then our M textures at 0 are going to be equal to a new texture, and this texture is going to be boss hit.png. And what I have here are the textures that I am using. So for example, I have boss hit and boss hit 2, which are a different color. And I also have the sound effects for the bosses. So I have here boss Galaga destroyed and boss Galaga injured. So I have the sound effects for these two as well, and we can call the sound effects in here. So let's first initialize the textures, and then we'll add the sound effects afterwards. So we'll say M textures at 0, parent is this, M textures at 0, position is vec2_0, and then M textures at 0, rotation is going to be equal to 0.0f. And this is pretty important since our entity is rotating over time, especially if it's diving. And if we don't reset this, it's going to have a messed up rotation once it replaces the texture. So make sure that you have your rotation set to 0. Next up, we need to change the second texture. So we'll just copy and paste this and change the zeros to ones. And then this is going to be boss hit 2.png. And that will be it for changing the textures for the boss. So if the boss wasn't hit before, we change its texture to the purple texture. If it was hit before, we just destroy the boss. By the way, this is what my enemy explosion texture looks like. So 1, 2, 3, 4, 5, and each one is 128 wide. So pretty much the exact same thing that we did for the player last time, but the player had 4, we have 5 this time around. We have to have the same distances between our animated textures or animated sprites. So that's why we have the same grid size, which is 128 in this case. Okay, so now moving on to our audio. So let's go all the way to the top. Right, we removed the handle that state, so we can just remove this from here now. And render that state, we can just remove this one as well, and then save that. And then at the top here, we're gonna say include audio manager.h, and then we're gonna go back down to was hit and say audio manager instance play SFX, and this one will be boss Galaga _injured .wave. Of course, you'll just change it to whatever your audio file is called, and then the loops are 0, and the channel, we want the channel to be 2. And the reason why we have it as 2 is because we want different sound effects in different channels, just so that the sound effects don't overlap. We are already using sound channel 0 for the bullets, so we're gonna be using 2 for this one, and then we're gonna be using 1 for the destroyed sound effect. So we're gonna say audio manager instance play SFX, and in here we're gonna say boss Galaga _destroyed .wave. The loops are 0 and the channel is 1, and that will be it for the hit function for our boss, and that's pretty much it for this class. So let's move on to our next one, which is the butterfly. So let's go to butterfly.h, and it's pretty much the same thing for this one too. So what we're gonna do is remove our render.state, we're gonna remove our handle.state, and then we are going to add our hit function. So we'll say void hit physEntity other override, and then we're going to implement this function. Now this is much simpler than the boss, since each of the butterfly and the wasp, they only take 1 hit. we'll also need to remove these two functions as well. So let's remove the render.state and the handle.state. We'll go to the top here and include the audio manager. And then we're gonna go down here and say audio manager instance play SFX. And for me, this one is called Galaga _ destroyed .wave, and that's the destruction sound for the butterfly. For the loops is 0 and the channel is 3. And then we'll say enemy hit other. So we're calling the enemy's hit function, and that will be it for the butterfly. Now, moving on to the wasp. So same idea, we're going to remove the render.state, remove the handle.state, and add our void hit override, and then implement this the exact same way. We are going to, maybe we can just cut this and paste it all the way at the bottom just to keep it consistent. We're going to remove the render.state and the handle.state, and then we're going to add the audio manager at the top. So include audio manager, and then here we're going to say audio manager instance play SFX Galaga _ destroyed 2.wave 0 and 4 for the channel, and then say enemy hit other. And that pretty much covers all our enemies that we have. Just make sure that you have the data files that we are calling here. So for example, the 2 boss hits, so these 2. We also have the enemy explosion that we added, so this one. And we have the Galaga destroyed 2, or whatever you call them. And I have the boss sound effects as well to add in here. And that's pretty much all we're using at the moment. Okay, so let's see what else we need to do here. So we can probably try to run this and see what happens. There we go. Okay, so there we go. So we have the enemies dying, we have them getting removed from the formation over here, and then we have them doing the sound effects. Also for the boss, we have them changing colors, and they are doing the sound depending on whether they got hit or died. So that's pretty much it for the enemy collisions. Now what we want to do is to add, there we go. So what we want to do now is to add the player score. And to do that, the enemies need to have access to the player. And to give them access to the player, we're going to go back to enemy.h and add a new static at the top here in the protected section. We'll call this one, so player pointer as player, and we're going to include the player here at the top. There we go. And then after that, what we're going to do is go to our enemy.cpp, and just like we did for the other static variables over here, we're going to say player pointer enemy as player is going to be equal to a null pointer for now. and we need a static function to assign that variable. So we're gonna go back to our enemy.h, and we're gonna go to where we have our static functions, and we're going to say static void current player. And this one is going to be taking a player pointer called player. Now let's implement that. So we can implement it under set formation here, and we're going to say sPlayer is going to be equal to player. And this way now the enemies always have access to the player to add score to him. So now we need to assign this value, and to do that we're going to go to our level.cpp, and over here in the constructor at the bottom we're going to say enemy set player, our current player, is going to be equal to mPlayer. Since the level has access to the player and the player is passed into it every time, we can just assign it this way. I think we are setting it somewhere around here. There it is. So we're setting the player to be equal to player, and then we are adding it to the enemy. So now we just need to add the scores to the player. We're gonna go back to every class that we have, so every enemy that we have, and assign a value to the player, so a score to the player. Let's start, I guess, with the butterfly since we're here already. So we can say sPlayer add score, and we're gonna say mCurrent state is equal to enemy formation. So if the butterfly is in formation, we want to give the player 80 score. Otherwise, we're going to give the player 160 score. So if the butterfly is diving, they get 160. If the butterfly is in formation, they get 80. And that's pretty much it for our butterfly. Now let's move on to our wasp. We're going to go down to hit as well. And we're going to say sPlayer add score. We're going to say mCurrent state is equal to formation. So if we're in formation, we want to give the player 50. Otherwise, we want to give the player 100. And that's it for our wasp. Now the boss is the last one that we have left. So we're going to go to hit as well. We're not going to give the player any score just for injuring the boss. So we're only going to give him a score if they destroy it. So we'll say sPlayer add score. mCurrent state is equal to enemy formation. What we want to give him is 150, but this is where it's a bit different, since if the boss is diving alone, they need to give the player less score than if they are diving with other entities. So if it's a capture dive, we want the player to be given only 400 score. If it's not a capture dive, we want it to give him 800. So we'll say another colon here, and then capture dive. If it's a capture dive, we want to give him 400. Otherwise, we'll give him 800. And that's pretty much it for giving the player score for each enemy differently. Now we need to have a way to update this score. So we're going to go to our screen manager, our play screen.cpp. And I think this is where we're updating our player. There we go. So in the play screen update, right after we update the player, we can say sidebar set player score to be equal to mPlayer score. So we're setting the player score to be the player score, and since we're already caching all the textures for the numbers, it's not going to cost that much to recreate the score every frame. So let's try to run it and see how this goes. So now we should be able to increase our score as we kill enemies. There we go. And depending on if they are formation or not, we are getting more or less score. And then the final thing that we want to do in this video is to be able to advance to the next level if we killed all the enemies. So let me try to kill all the enemies here first. There we go. So right now we're now moving to the next level, and we have it set so that if we press N, we move to the next level. So if I press it now, we're incrementing the level, but we need that to be automated. So when the last enemy is killed and they finish running their death animation, we want to be able to move on to the next level. So let's do that then. Okay, so what we're gonna do is go to our level. So our level.cpp, we're gonna go down to handle enemy formation. So all the way down to handle enemy formation over here. And we're gonna start by creating a boolean called level cleared. And this is gonna be equal to m spawning finished. And the reason why we're setting it to spawning finished is because if we're not finished spawning yet, what we want to do is to wait until all the spawning is finished. So the level is never cleared unless the spawning is already done. Now, to move on to each one of these, we're going to add a bracket here. So for this if statement, we're going to add a bracket and put this in here and say if m formation butterflies at I current state is not equal to the enemy dead, or m formation butterflies at I in death animation. We're going to say that the level cleared is equal to false. Okay, so let's explain what's happening here. If there is an enemy that's not dead, or if there is an enemy still running through their death animation, it means that the level is not cleared yet. So we can't move on to the next level. So this is the idea here, is to run through each one of our enemies and make sure that they're all dead and they're all done running their death animation before we move on to the next level. So let's copy this if statement. What we're gonna do is add the bracket here, move our formation update to be here, and then instead of formation butterflies, we're gonna change it to formation wasps. And then we're gonna do the exact same thing for the bosses. So let's cut this, put it here, and then copy this if statement, put it there, and then we're gonna change the formation wasps to formation bosses. And that will be it for changing these for loops. Now, all the way at the bottom, we can say if level cleared. What we want to do is to say m current state is going to be equal to finished. And that will end our level once all this is true. Now, we need to go down to our update for our level update and remove the n equals a finished level. So we can just remove this and just say if the player is hit, handle the player death, and that will be it. So let's try to run this. There we go. So we killed all the enemies, they disappeared, move on to the next level and start spawning the new enemies. And yeah, so now we have our level progression in the game. Next video, we can probably implement our more accurate collision detection, which is our box collision. but that's for the next video. I really hope that this video helped. If you have any questions, suggestions, or feedback, please let me know. Otherwise, thank you very much for watching, and I will see you in the next video.